Yeah. Yes. Going on.
Yeah. It looks like maybe something about unplugged.
Maybe take it out of the computer and in again. Yes. Don't take the plug out. Somebody to get don't take it out, else nothing will work.
So as you can see by the screen, we have made progress to the point of connecting at least one laptop. So we're connecting another. Give us just a few minutes. Thank you so much for your patience. Continue to talk and I will be loud and interrupt again when we're ready to kick off. But just a few minutes and we'll get started.
I haven't deleted
So what are you talking about? Free university. It's a teaching hospital, so the surgery they do somewhere else.
You want to ask them? All right, we're going to get started. Welcome, everyone. Space is at a premium, which is fantastic because it doesn't feel like that's a thing post the last 2.5 years. So I'm delighted that space is at a premium. If you have space next to you or you're in the back and want to sit down, grab a chair, fill in the area. It's ours to use as we see fit. Quick housekeeping item. You'll see around the back little sign up QR codes for the newsletter. Check it out because the human who was right here, who just walked away, Christoph back there, wrote an amazing newsletter for June covering things like memory overcommit, query of the month. We don't spam you. It's worth it. Check it out. This is our first time getting together. It's our first time getting together, not only in a long time in Amsterdam, but for a number of us in the ClickHouse team, it's our first time getting together. And so I wanted to start with something simple, which is to introduce you to and invite each of them to say something from the founding team. And I went one slide too. Oh, no, I just went, moved it. There it is. I found the slide. This is our founding team. So I'm going to pull the mic off, ask Alexei and Aaron, and then I'll carry the mic over to Yuri so that he doesn't have to climb up on the stage with crutches, and ask them each to say something.
So, welcome to 59th ClickHouse Meetup. And this is not the first meetup in Amsterdam, but the first after a long 2 years gap. So, I'm very happy to see you again in person, live. And today, you will have a chance to ask any question you want about ClickHouse, and we will uncover all the secrets. And let me also introduce my friend, Aaron.
This is a big event for us. This is the first physical time that Alexei and Yuri and I and the broader ClickHouse team have gotten together. And we formed a company around this very powerful technology that Alexei and Sasha and Nikolai and others created inside Yandex. And Alexei and I met over a year ago, and we started to talk about what it might look like to form a company around this very popular and powerful analytical database. And it took about 9 months to formulate the company, ClickHouse Incorporated, in the US. And we recruited Yuri Israelevsky, who I've known for many years, an old friend of mine. And I first met Yuri when he was running engineering at Netflix. And he had since gone to Google, and we recruited him to join in the fun, and we formed this company. And we're just so excited about the growing community that we have and the partnerships that we formed, and meeting people like Lorenzo and others. And I'm really excited to hear from them. So we're super grateful for the support that the community has provided to the company. Robert, nice to see you, for all your years of supporting ClickHouse as well. And just want to welcome you, and we're here to ask and answer any questions that you may have. And so with that, why don't I hand it over to Yuri?
Hello. Hi everyone. My name is Yuri. So excited to meet everyone. I've been working in the open source for close to 25 years now, but in all of those years, I've never seen a community so vibrant, so strong, so exciting as ClickHouse. It's really amazing to see. And I know all of us are working at different companies, different organizations, but we're all trying to solve the same set of problems: scalability, performance, reliability, security. So hopefully we'll all learn from each other, work together, and solve those problems together. Thank you for coming.
A meetup is only as good as really two things: the content that's created and the folk who show up. So for the folk who showed up, thank you. For the content that's created, I'm super stoked. And with that, I am delighted to invite for the first presentation, Lorenzo. I will let him introduce himself because he is a fully realized human. But please join me in welcoming Lorenzo to the stage.
Adjust here a little bit. I move my head a lot. This is going to be messy. Wave at me if you can't hear me or if I'm, messing up. So, try to jump to my slides. Do you have it looking all right?
Yeah, it should be.
Here,
let me grab it for you because it's easier.
And so. All right. Okay, I'll be blowing my nose a lot. That's what I do when I'm speaking. It's like kind of a... So, mic is working. You hear me all right?
Can you speak a little closer to the mic?
A little closer to the mic?
That's
Like that?
perfect.
All right. All right, my name is Lorenzo. I run Pixit and Uptrace, two tiny companies that made a little fortune in their road using ClickHouse. So heavily in love with ClickHouse and using every day to run our business. I'm an open source maniac. Like nothing else makes sense to me, and sometimes I also work on other stuff. But if I could, I would work for free and just do open source, to be honest. I have an amazing team, decentralized really by now. I'm basically the only one in Amsterdam with some of my other ops, and we're obsessed with monitoring, ingestion, tracing, packets, whatever it is. Like we dedicated our last decade just to collecting data and creating solutions for people that have like data problems. Not the standard type, so we tend to like work on oddities projects or people that need a little more than normality to succeed. And of course, ClickHouse is the platform to do that. We're of course proud members of the community, some more, some less. I guess you don't know me much, but Alexander and some of my other guys are actually members of the original communities, Russian-speaking ones, where the real talks take place or have been taking place for the last few years. We run a bunch of ClickHouse servers for our customers, mostly on-premise and support. I think it's over 100 nodes that we run on top of our applications, which are various. One is Uptrace. We have Siloki, which is now one with Uptrace. We have Happy, and we have other projects. ClickHouse. That's all we use. That's the only database that we build solutions with. And today, actually, I'm going to tell you a little bit about that. So the menu today is to tell you the tale of our two projects, which are Uptrace and ClickHouse and Siloki, and how they became one over the last few months, mostly thanks to ClickHouse and the way things work. I'm going to tell you what they're for. I'm going to tell you why we did it, and basically what it's running on. But starting from the top down, I don't know how many of you, maybe raise your hands. Anybody ever heard of Uptrace or Siloki up until so far? Okay, that's more than nothing. Thanks. So, two different projects, both spinning out of the ClickHouse ecosystem. So, started independently. Uptrace is an OpenTelemetry platform. So, it's strictly implementing OpenTelemetry specifications. It's compliant with all of the instrumentation they provide. It's designed exactly to solve that problem. With a few specialties. So, it's a big collector that can be connected to the OpenTelemetry clients. Source, of course, everything in ClickHouse, a well-structured, well-defined system that works in a predictable way. On the other side, Siloki is something that we have created for the opposite side. When you're collecting data, you don't know where it is, you don't know what format it has. It spins off from Grafana Loki, so it's built on, let's say, the same API and the same assumptions, but entirely on top of ClickHouse. So we wanted to create a tool for our customers first, so it doesn't, spin off as a project that wants to be for somebody. It was created to solve a very specific set of problems that we had in the telecom space, where we wanted to collect something without knowing what it was, without having to, pretend that it never changes, and with the ability of storing a lot of it without looking. Most of our customers, they will access maybe 1 to 5% of the data that they store. So they ingest a massive amount of data, and then they only use a little. So we wanted a system where we could ingest for cheap and where we could query, hardcore using all of the ClickHouse features. So it implements LogQL and PromQL query transpile. So basically, we transpile those queries to become basically ClickHouse queries, and that's what we've been doing for the last couple of years with that project. If you want to make an analogy, at least the way I see it, Uptrace is like Lego. You have very specific blocks. They always work. You can make a very solid structure with it. You can, engineer using those pieces in a predictable way. And Siloki is more like Lego. It's just something that you're going to mesh into what you want when you want it. So it's not something that, of course, you're going to use every day. But when you need it, when you need to make that little special thing quick, that kind of works. It's got all the palette and the same stuff as Lego, but you wouldn't build a house with it. So it's a tool more, it's a different kind of knife that we use to solve specific issues. Again, we're both coming from the community. So, I think that's the beauty, the real beauty of ClickHouse is that it has an ecosystem of people that actually want to do something with it. It's not like a normal database scenario where, hey, here's a bunch of guys that just, use a driver and that's it. I met the majority of people using it. They are trying to push the limits of something. and they see ClickHouse as the platform that they can use to do so. So to me, it's like kind of a startup accelerator of its own if you're dealing with data. It's an engine that you can put under your idea, and it already does, a whole lot of things that you would otherwise have to reinvent. Alexei and the guys did a great job creating something that's usable in real life. You can do something with it. So there's a lot of projects floating around. Not all of them survive. So if you follow ClickHouse projects on GitHub, you know that many of them are born and dead, within a short period of time. Many of them said, we're reinventing logging with ClickHouse or something with ClickHouse, but sometimes it's just good ideas. In making CLocky and Uptrace, we have tried to absorb everything that was good about those ideas, including some that are just abandonware by now. So still good. So we survived, let's say, the incubation phase. We have users, we have use cases, and we're not just a couple of projects on GitHub. But we have been competing basically all of this time. So Uptrace and CLocky start again from diametrically opposite directions, but eventually we started crossing over. So we started adding telemetry features to CLocky, and Uptrace started adding logging features to their stack. And before you know it, we are overlapping. And what do? So the options were either competing or joining, and that's what we did. So after, we both built on top of ClickHouse all of our ideas. So when we basically, sat down on the table and combined and compared what we were doing and how, it wasn't that different, thanks to ClickHouse. We were using standard methods, things that we learned from, these meetups, from, all of the blog posts, from other people's code. It tends to come together. Like there's not, too many ways to do things right in ClickHouse. So if you follow, the specs and you do intelligent things, they turn out to be quite compatible. So we just merged everything. And as of now, actually speaking, we have one combined team. Some of my guys are here with us. There's Alexander Dubovko, who's been running things with me. Actually, is the guy that forced me to consider ClickHouse for our projects. When he did tell me the first year, that's like, everybody said, you're crazy. This is not going anywhere. I was wrong. Why I was wrong? So we have a nice team of fanatics. We live, breathe ClickHouse and ClickHouse programs all day long. And we have now a nice stack of projects. So CLocky comes with a bunch of, with clients. He has a UI, he has integrations, he has a CLI, and Uptrace as well. He has drivers, he has open telemetry wrappers, he has specialized ClickHouse drivers with telemetry built in. So when we combine all of this, it became like a fantastic, bucket that we can now use to solve a bunch of different problems. Sorry. So there's only Uptrace for now. If you have heard about CLocky, forget it, it's gone. Now it's part of Uptrace, and they're just one fantastic, majestic project that does multiple things, and we'll see how. So we can forget the name and we can just focus on this new brand, sure. Which by the way, if you can prove me you're a user, you'll get one right away. So what is the new Uptrace? It's not anymore just an open telemetry platform. It's more of a Swiss Army knife type of tool. So we can still take all of the data that we used to, so open telemetry and all the stuff. But now we can also ingest logs. Now we can also ingest or act as a Prometheus remote writer on top of ClickHouse. We can serve log.ql queries, PromQL queries. We can take InfluxDB formatted data. We can take Elastic ingested data, and a bunch of other things. They all shrink down into our two schemas. Either they become something that's looking like telemetry or something that's looking like log. The point of this is not to force people to install or reinvent the way they're producing the data. So this is compatible out of the box with existing agents. You can use Vector. You can continue using it. Use Telegraph, use, Logstash, Promptail, whatever it is that you were using to collect logs. You just add a new sync and send it to our collector. So it doesn't force anybody to reinvent the wheel if they just want to give it a try, right? Everybody already has something, whether it's good or bad, it doesn't matter, but they have it, right? So this is our way of being pluggable, really, really easy. So it doesn't cost anything to try. It doesn't cost, re-engineering or anything like that. And we retain a couple of cool features. So Uptrace has its own UI, but all of this is also accessible through native integration. So we spent the majority of our time actually keeping everything one-to-one compatible with the Grafana APIs for GraphQL and Tempo. So this might be one of the few products out there that you can use from Grafana without installing any plugin. It doesn't require any plugin, not even the ClickHouse one. So it talks protocols that they have designed for themselves and that we have re-implemented. It's a little bit like, I don't know, it sounds evil, but it's the AWS way, right? You can take an API, right, and put it on top of whatever you want and make it work. And all of a sudden you have the same functionality or similar enough functionality, and sometimes even better because we beat them at their game. This is the example. So you can use the log browser and access Uptrace and Siloki, just like if they were Loki and Tempo. So Grafana doesn't know that it's something else. It's the full API with tags, with ops, all of the functionality, 100% with actually 101%, because ClickHouse has special powers that they don't yet have. So standard protocols, and so you can build whatever you want. You want to make your dashboards, you want to port them over, do it. But the Uptrace UI is a little bit different. So we don't try to reinvent the Grafana game there. We have something that's actually going to help people do the job, or this is how we intend it. So the dashboards of Uptrace, they only talk about what's going on in the system. They only tell you about the services that we're tracking. They tell you which one of them are failing. They immediately can pinpoint you at a specific information. What's the slowest performing service? It's right there on the homepage. One click, you got it, and you can jump into the trace. So you can go from an umbrella. Those are the failures. Those are slow performing services, whatever it is. In one click, jump into either the telemetry, the tracing, the logging, or the metrics that you have collected for that entity. So a service can be observed, from any of those angles, basically at the same time. Whether you want to make charts, make alerts, make detections, we don't decide that front. It's just like bringing up basically outliers and then assembling everything in the, let's say, classic telemetry fashion. So it's cascading events, everything kind of a parent and a child. It's easy to create correlations between events, like an API. In this case, this is a WebRTC call of all things. So it's not just for data, it's for protocols, it's for communications, it's for APIs. Here we have a session, something is connecting to an API. It's a user that's joining. They do a ICE negotiation with the server to open a WebRTC port, and then they start exchanging data. This could be, at once looking at the connectivity between the user and the service, what the service is doing inside, which function is it calling, how is it working, and then how it's connecting to the other party all in one plane, which in my experience, it's a rarity out there. And that's a broken slide. And there you go. And this is how it feels. I mean, using it is just basically clicking around. It takes away, unless you're, going for something specifically, the need for searching or knowing what you're going for. You open it, you find some trouble, you start browsing around, you find where it's coming from, what it's generated by, and then, most likely you pass it over to somebody to fix it. And as we said, within the same UI, now we have 100% of the logQL functionality as well. So within the same simple, nice UI, you can jump from telemetry to traces. Here we see we just little query, getting logs sent by vector. We're going to need a bigger boat, parse it as a JSON object, and off we go. And that's the cool thing that we have, is that you can jump from log to a trace. So if your application is logging about something that's also being traced, we can have automatic identifier. And here, just find trace takes me to the trace. So jumping from a log to metrics or open telemetry and backwards all at once. So we're trying to create a loop so that people don't have to leave their workstation or use 10 applications or copy paste or even configure anything really. You just vomit all of those formats all at once into ClickHouse, and we offer the same APIs for clearing them out. So just keeping it simple on top of one database, and that's what we do. I mentioned it before. This is a screenshot of how it looks like. So the same experience that we have in our UI, where I can go search for logs, find the correlation, is available in Grafana as well. Again, 0 plugins, no plugins at all. So we can use the Tempo beta search to actually access the Uptrace API. It resolves hosts, it resolves services, it just returns everything that the API expects. Plus, we support wildcarding that they don't. So in their search, you can only search for something that exists, and it's only there if it's there. In ours, you can do hello wildcard, and you will find everything that starts with hello, or whatever ClickHouse allows. So it's way more powerful. And as you see here, it just creates these nice jumps between technologies. Totally transparent, and it's up to you how you use it. So whether you're sending logs, API logs, your custom objects, the errors of your application. It doesn't matter. You don't have to worry. If you know the format, you format it. If you don't, you just throw it in there and you figure it out when it's time to query in terms of how it is, how do I find it, and how do I use it. If you know anything about LogQL and Loki, it also allows going from logs into metrics. So we can parse our logs. We can, use regex, JSON, logfnp, or custom parsers to say, take everything, extract, a number that could be the memory that we're reserving or something like that, and turn it into fake metrics. So we can extract values, we can extract tags, and we can present them to Grafana as if they were collected metrics, but they're not. Those tags don't exist. You didn't have to decide last month, how am I going to tag those metrics? Am I going to use the host? Am I going to use whatever else, the name of the service? Forget it all. Just send a log, make it bloated, leave it all in there, and figure it out when it's time to query. It's cheaper than figuring out when you're inserting it, in our experience. This is how it looks. So ClickHouse logs, right? We all use them, I guess. If you don't, you're missing out. This is just a silly example. We're looking for ClickHouse logs that contain the word reserving. So we're filtering them all out. From this, this is the most expensive way to do it, but it's also a good example of flexibility. We extract a token that's going to be just the memory that we're using, and we put it in a wrapper. Average over time of this value extracted from ClickHouse log, partitioned by any, let's say, time window that you want. In this case, I'm leaving it by seconds, and grouped by the type where you see there. That's the group by, which can also be a tag. So you can extract something that becomes a group, something that becomes a metric, and boom, there you have it, without having to think about it before. Am I going to measure it? Should I track memory? Should I don't? You don't care. You just figure it out when you need it. If it's in the logs and it has a number or a string or whatever, you just grab it out and use it right out of the box. Just as simple as that. Under the hood, again, just to for full transparency, it's all existing agents. So zipping format, OpenTelemetry format, browser logs, JSON, logfmt, Kubernetes logs. It doesn't matter. They all have a driver for either Loki or for Prometheus or for OpenTelemetry. So you have the option, many times multiple options in terms of how you're going to plot your data into this platform. It's either one of these three columns. So depending on the format that you choose, we emulate it. So we either consider it logs, metrics, or OpenTelemetry. They end up in different buckets, but they stay within ClickHouse, of course. So all of this data is reachable through any of those APIs. You can query telemetry as if it was a log, or you can extract some metrics from telemetry from the PromptQL language. It's a mesh, and probably it's too much. It's going to probably simplify itself as we consolidate what users actually want. But today, it's really Swiss Army knife. All the backend is made in Go. The majority of it is on Meetup, so super transparent. And the idea here is to bring your own ClickHouse if you want. So we have a cloud offering of our own. If you go on ClickHouse, on uptrace.cloud or .dev, you can immediately sign up and enter. It's free for small accounts, just like everybody else. You have a little bucket where you can send data. If you want, you can buy more. But if you don't, you can just bring your own cluster. And actually, we have a demo running on ClickHouse Cloud right now. That's doing fantastic. So that's a great pairing between the two, Uptrace and ClickHouse Cloud, mostly because they do the job for you, so you don't have to worry about how it goes up or down. And this is an example of actually how it runs. So we're, I called it 500,000 per second. This is on a 4-core system, super small, with a little more than 2.5 gigs, where we can stream an incredible amount of events. This is mixed. It could be all of them. It could be all logs. It could be a mix of logs and metrics. It could be telemetry. It just can take really a beating. And again, the majority of this data you're never going to look at, most likely. It's just going to sit there and be ignored. But in between, there's the needle in the haystack, which is really what we're after, is giving you a quick way to do it with a low performance. We try from a benchmark perspective to keep close to like Victoria Metrics and other platforms that really are pushing the limits. So we're pretty damn close to that, of course, thanks to ClickHouse. Not really. I mean, we're doing the small part of it. You can see here, it's only one thread that's running our application. The other three are, of course, running raw ClickHouse file. It's all about ClickHouse, right? So there are no secrets here. All of you already know what ClickHouse is good for, and our project is simply about using it smart. So we're not trying to reinvent the wheel. We're not trying to do anything that's incredibly fancy. These are lessons learned from this community, from the blogs that this community produces, and all of the articles and whatever. So under the hood, it's nothing special. We didn't invent or write anything spectacular. I think our art has been keeping it simple and acting according to design. So the things that we use are actually super standard. I would be surprised if this is not something that all of you use on a normal day using ClickHouse. So sampling data, and I'm not going to stay too long on these slides because they're not my specialty necessarily, but simple downsampling. This is key in Uptrace, so it allows us to return approximate results for a fraction of the cost. I think it's a technique well known to all of you guys. Tight storage, so moving data between SSD and S3, which, by the way, in ClickHouse Cloud, it performs extremely well now with the caching, is also one of our major tricks. So keeping hot data on SSD, and then cold data can be easily moved to S3, where it's only going to be, again, accessed rarely, and it can be a whole lot cheaper. Using codecs and compression all the way. This is something that my guys in my team are obsessed about. They argue about it almost every week in terms of what's going to be best to do for either the existing stack or what's coming next. Crucial, of course, to succeeding at scale. And the table engines. I think we couldn't go anywhere without the merge table engine and distributed table engine. We just wouldn't exist. Half of the things that we do are depending on the features that they bring to the table and how simple they make complex operations, and taking away all of the needs for moving data around, just giving us this nice pod on top of our tables that can be connected. I've never seen this on our database. It's so simple, and we just love it. All the way to creative usage. Like this is something that one of our engineers is testing in ClickHouse, so creating a gene index, just like it would have in other databases to basically accelerate. And we're testing this against, for instance, skipping indices, which one works best for a use case. So whether you're doing standard things or you're doing your own way, it works. And I decided to put this at the end because, of course, it fits 100%. So this is how it all started, with this little slide that was on the ClickHouse documentation about sending traces that ClickHouse is already connecting to a collector. It didn't specify which one, using a URL engine. So this is like everything that I love about ClickHouse in one screenshot. It's a materialized view that's pulling exactly the data that I want, and then it's sending it to my API exactly in the format that I want, and I had to do absolutely nothing. So all we did is just build on the other side of this. It was just doing exactly the job, and you can see how it turns out. So when this is enabled, and if you use a client that generates telemetry, in Uptrace, it looks fantastic, and know that we designed it around being ClickHouse users. So I'd be extremely curious to see if it accelerates everybody's troubleshooting the way it does ours. And it's all there. There's another little thing that we have that's called ClickHouse Mate. This is our take on ClickHouse Play. And it's our UI. This is the hypervisor that we use to do our job. So, Alexander likes to call it the PHP MyAdmin of ClickHouse, which I guess is a funny name. And yeah, this is also one of our projects. We have a lot of little things around our products. That
But
we
there's
like
no
to release.
PHP.
There's no PHP, I promise. It's just the name. And that's what we do. So our roadmap is incredibly active at the moment. So I even had a hard time putting it down today. I saved it for last. Multi-tenancy, we finished it before we came to this point, which was the last feature that was part of our merging CLOC and Uptrace. So that's a partition system, which, like many others, it just allows you to create a user, give you a key and an endpoint, and then we can have the system figure out how it's going to distribute and store. PromQL API support for open telemetry. So we already had PromQL support for reading from the CLOC tables, where we could basically act as a remote writer. But now we ported it also on top of the open telemetry API. So all the metrics that will be sent using open telemetry can be queried using PromQL. And this is pretty significant because it means that a lot of people can migrate a bunch of widgets in an easy way instead of having to reinvent it all. It makes that exercise a lot easier. JSON data type, we're rushing to do something with it. I think at this point we're not there yet, but our guys are excited and playing with it just to see how it compares to the way that we've been doing it so far, which was diametrically opposite. So we were not touching anything, writing logs without even knowing what format they had. This changes the game. We can't wait to see how it works. Additional import formats, and this is more up to the community than anything else. Like we already have, what we thought, were a stock of super compatible APIs, LogQL, PromQL, InfluxDB and Flux, Open Telemetry, of course, and we have then also ingesters that emulate the Elasticsearch index and bulk APIs. So you can also point and send all of that garbage, just JSON again, right, into our collector and just query it using LogQL or whatever you want. So it gets actually pretty fun, if you're building something. We also emulate the Alert Manager API as part of the product, so that the Grafana features with alerting and everything that's pretty much considered standard in that realm can be ported over as well. And if we did a good job and we're lucky, it should be extremely simple to port something that you're using with either, I don't know, Grafana Cloud or your own Prometheus or a mix of your solutions into this one. And hopefully the best part of it all is that at the end it's ClickHouse, right? So all of this data ends up in a table, and that table is yours. So whether you like the way we did it with our API or whether you want to take it to the next level, it's your decision. It's that table, it's yours, build on top of it. So we hope that actually, we end up being more just of a great, fantastic ingestion layer for multiple protocols that will allow other companies to also build on top of that success. I guess time is up. We have lightning talks, and I don't want to take too much time, so we can wait for you guys to join the Uptrace party. We have free, totally free, no strings attached, just an email away, and we don't spam you that much. To get into the system, you can use it and use the majority of the features. Right now, there's a little difference between the paid and the free accounts, which is exactly the login and the metrics part, but I want to unify them. So eventually, you will be able, even with the free option, to try everything that we have to offer. We also have on-premise. That's actually something that's major for us. Many of our large customers just want to keep everything for themselves. So we also run this in a specialized fashion, let's say for special projects. So it's also flexible for them. Cloud for everyone, but if you're running something like really special, really tedious, or that you need to build on top of, it's flexible for that as well. And that's all I have, folks, unless you have questions or something that I can answer. It's been a pleasure, and thank you for having me.
Awesome. I'm actually going to give you the mic real quick. We actually, Lorenzo, we did have a question from YouTube, but I just found out that mic over there doesn't seem to work. So I can't ask you from there. So I'm going to ask you from here. Maybe this was previously, and I apologize if so, but why did Uptrace decide to write their own ClickHouse Live instead of improving the official Go driver?
Absolutely. Telemetry. That driver only adds telemetry. So that's all it is. It's basically the Go Faster driver, right, Alex?
Okay, it's two drivers. It's Go Faster,
Yes.
And he has also own driver.
Yes, but the reason for the driver to exist is purely telemetry. So it's a driver that can measure what it's doing. It depends. If you control your own ClickHouse and you can get telemetry out of ClickHouse, then you don't have that problem. But if you don't, if you're using somebody else's ClickHouse that doesn't give you telemetry, then this driver does. So it just tells you how good or bad it's doing as it's working. That's the reason.
Awesome.
Thank you.
Thanks heaps. Beauty, we're going to move straight forward into lightning talks just in interest of time. Lorenzo will be here, I assume. You're not running away? Yeah, cool. So, yeah, wise man. So we're going to dive right into lightning talks. So with that, let me preamble while we invite Ilya to the stage, who has to fight through a sea of humans wearing ClickHouse shirts in the back of the room. Awesome. So with that, Ilya, take it away.
Hi, I'm Ilya, and I work at ClickHouse for 3 years, I guess. So probably I know some of you by like your nicknames or personally. And I know that there is a live on YouTube. So hi all you for watching remotely. So lightning talk, just a couple of minutes. So how we like test ClickHouse using benchmarks. We have standard hardware benchmark, and I guess you saw it like hundreds of times. And what we usually do in this benchmark, we just download data, download ClickHouse itself. It's like trivial as it is. You can see like it's one batch line, so and you have ClickHouse here. Then we actually, for each query, we run it 3 times, and before running it, we drop all the caches to see like how system works without caches and with caches. And so we do it like for every hardware that we or you want to check, and then upload the results to like our report, and you can see something like this. So here is like how you can reproduce it by yourself. It's just like 3 lines of bash, and you will see all the results for your own system. But it's not what we're talking like today on this lightning talk. You can see something like this: green and red results, and you can show you how your system works. For example, some queries are telling about like, how your CPU is better than other, or how your disk is like slower or something. You can compare with like different types of instances without running by yourself these tests, because it's like standardized. But you cannot see the throughput of the system using these tests, and there's no cost in these results. You can't understand which one is like cheaper for your workload. So that's why I have like the next couple of slides. So we want to check cost effectiveness and how we can do it. So we wanted to like check throughput. Then we wanted to understand like the costs and normalize to it, and choose something. How I just try to do it. So I got all these like 43 queries that you see like every time, and I use like ClickHouse benchmark tool that runs several queries one by one. In parallel, I used like 10 threads and looked at 2 interesting or 3 interesting instances. And here are results that I got for it was all on AWS with the same storage, and I like normalized to cost of gravitons. Like the current version that like 2 weeks ago was NJ and Intel and AMD. And we understood, like, for example, if you compare the performance and throughput of ARM instances, like in comparison to like normal ones, is almost 2 times cheaper if you like look at all the queries. Some queries really are also like 2 times faster, but some of them are not as good. So actually, it's a really good result. We haven't tested Arch releases before in our CI, so we had like performance tests for each commit, each pull request for normal builds. But like in previous week, we added tests for Arch also, and we haven't like invested much in optimizing this like ClickHouse version that works on, for example, Gravitons or other Arch64 platforms. And even like without optimizations, we have like cheaper and faster results. So there's one example how you can like compare them. And what we do next, we want to see like all these queries or other queries, how actually they compare between these 2 platforms. And because like if in some of them we are slower, that means that probably we can just fix it and make it faster. So and also like in the previous steps, I had to like choose which parallelism I want to use, and it's not so good in terms of sometimes your queries need more memory, and at this point it's like not easy to understand how much queries you can run in parallel. It really not so good now, and we know how to fix it. So I guess at some point you will just like send all the queries, and it will choose which parallelism to use. So I guess that's all. If you have questions, I can answer that.
Awesome. Thanks heaps.
It was like lightning.
It was lightning. I'm super impressed. So we'll continue forward. It's just so tempting for me to just shout, but I want to respect those of you who are on the live stream. Hi, we care deeply about you. So I'm going to talk into the mic where I can. So the next one, continuing forward, lightning talks are lightning fast, is Riyadh giving us the 5-minute logging story.
Thanks, Tyler. Hi, everyone. So, yeah, I prefer holding the mics like Rolling Stones style. So, my name is Riyadh. I'm a consulting architect at ClickHouse. Nice to meet you, everyone. And I'm here today to talk about the history of logging website. Well, let's say you're a sailor and you're on a boat in the 16th century. You just left the port of Amsterdam, heading west to what we call now Canada. And after a few days of sailing, you're surrounded by the sea. So how do you locate yourself? Where are you now on the earth? Anyone?
Stars.
Stars. That's a really good proposal, actually.
GPS.
So you do it? Yeah, GPS. So the stars is a good proposal. That's how the Phoenicians or the Egyptians or the Greeks did it. They looked at the stars and they tried to figure out where they were. It works really well to figure out your latitude. So where you are on the north to south axis, but it's not great when it comes to longitude. So we still have half of the problem to solve. So anyone else?
Clock.
Sorry?
Okay.
Logging?
Dead recording.
Dead recording. Yeah, it's taking like looking at landmarks on the way. That's a good idea. It's actually close to dead recording, so I think that's a good answer. So the way they did it is that they throw away something over the deck. It will float, and then they counted the time it takes for the ship to pass through this now static point, which is similar to what dead recording is doing. So they get an idea of their speed, and speed plus time is enough to compute distance. So that's how the captain kept track of his path and where he's heading with his 100 men aboard the ship. So it's a big responsibility back then, but it's not that accurate. So in order to do it accurately, you need to repeat the measure quite often and keep track of all the measures and write down the time at which you took the measure and how you did on the speed level. So this piece of wood you just threw is called a log. It's a log. And this book where you are writing down your notes is the logbook, and that's where basically the logging term come from, and that's what we use right now. And you see, as a data structure, it hasn't really evolved that much to be honest. It's very much the same thing. It's a timestamp, a kind of status, and some metrics and some message associated. So now a big leap ahead, 500 years later, to operating systems. So everything is a file. It's not a quote from the movie The Matrix. It's actually a Unix design principle. Everything is a file, and the Unix systems, it ends up in varlog, and it can quickly fill up this folder if you're not tracking it. A lot of sysadmins know that really well. And if you're not really looking into that closely, some systems will break. Like, for example, the Sun Java web server in the late 90s used to break at 2 gigabytes of logging. It just stopped logging. I don't know if you noticed, it's a 23 years old typo here. We see, so that's also interesting. And you see that it's not that easy to keep your logs straight. So some people had the idea of centralizing logs. That was a very smart thing to do, actually. If you operate many heterogeneous systems, at some point, it's easier if you centralize all of this. And syslog came thanks to Joshua Weinberg here. But this community was really a sysadmin-focused community, and they thought of it as a networking problem, like something where data is here, we need to move it over there. But they didn't really thought about how do we store these logs now that we had them. We kept them in a file format or something. And back in the late 90s, early 2000s, was the golden era of the relational database. So people thought, okay, let me put my logs in my database. That's what I have. I have Oracle, I have, I don't know, SQL Server back then, or MySQL in the early days. with PHP and you use that to store your logs. Actually, not a great idea because it's a very rigid thing to do. The model is really rigid. It comes with a huge overhead, and that doesn't really play well with the nature of logs and how they work. So a decade later, or even before, some people started noticing this problem, and this visionary paper from Michael Sonbreaker really said that we need to stop with this one-size-fits-all model. The relational model is great, but not for everything. So a few years later, the industry replied, and we saw the rise of the document stores, the NoSQL era. Like, bring your data as it is, dump it in there, we'll index it, we'll store some metadata on top of it, and we'll give you the ability to query it on the fly. So it's great because as a user, it's very comfortable. You just write like non-structured search queries and you get your results, but it comes with a price of storing inverted indices, a lot of overhead, less schema, but very often inflating the volume of data. And here comes, I guess you know it, ClickHouse. As actually a true column-oriented OLAP system, ClickHouse will treat every column in a separate file, which is, actually, if you think of the data structure of a log file, timestamp against status, message, maybe metrics or something, it's very smart because you can group together the same data sets and benefit from great compression ratios. Like if you use things like enumeration for stages, for example, you get one of the best ratios out there. And then adding to that, a very powerful analytics capability, SQL, even more than SQL, ClickHouse SQL, a horizontally scalable system that can scale to millions, like Uber or billions, or like Uber did with their logging platform. You can have a look at our website if you want more details about this use case. So I don't know if you noticed, but through this lightning talks, I sneakily positioned ClickHouse as the ultimate step of the evolution of logging systems. So you either agree or disagree with me. I'll be happy to take more questions during the coffee break. Thank you.
Unfortunately, the beamer is not quite as high resolution as you may hope. You can't see that the evolution of man exists in silhouette on that screen, like the famous image, or you may be able to. I can't from here. It just makes me incredibly happy for that to exist as sneakily positioned, the evolution. Even more sneaky than you thought, Riyad. Awesome. Moving on to the next, it is truly a privilege and a delight to invite Misha to the stage to share with us ClickHouse anti-patterns, which are always some of the most important patterns to learn. Misha, welcome.
Hello. Yeah. Actually, my name is Mikhail Filimonov, and
so sorry.
Yeah. And today I'll speak about actually one anti-pattern because there are a lot of them. First of all, what is anti-patterns? Yeah, there are a lot of things we do a lot. We repeat them again and again. And we can call them patterns. And sometimes those things they end up not so good as you expect. And you can say that it is anti-patterns. At my job in 1980, we saw a lot of different schemas, a lot of different setups, and it's at that time I have enough information to tell about like dozens of different anti-patterns, but today I'll speak about one of them. Let's try to guess let's see if you can guess what is the problem. And I'll just we'll show different reports which were reported really by real users, and like one after another, and who will be first, who will be able to detect what is the problem. I will not read it aloud, so please read it from the screen. Okay. Somebody? Okay. Okay, that's strange. Backups. Zookeeper. Connections. No free inodes in the file system. What the hell? ClickHouse collect a lot of inactive parts and can't remove them. What the hell? Optimized file is very slow on a small table. There is the replication issues that like high zookeeper traffic, there are some delays. Too many parts. Insert goes slower when more data were collected. Okay, so initially it was fast, after that it gets slower. ClickHouse server starting up takes 40 minutes. Oh my god.
Over 10.
And the final one, now you should know the answer, guys. I see. I know, Alex.
So ClickHouse has been built in debug mode.
Yeah, it's so many problems, and the reason is bad partition by. Oh my god, like a single statement when you create a table, and so many different problems. But today I'll not say about all the different kinds of bad order by bad partition key, but on one particular use case which really is a pattern, which often repeats again and again. So when you have a company, you have different clients, different tenants, and when you have a partition key, people tend to use that for splitting tenants into different groups, or using what partition by tenant ID or partition by tenant ID plus some, for example, month of equipment. And what is the problem here? What's wrong with that? So let's remember that partitioning is a physical separation. So every partition will be processed separately. It will be stored separately on the disk. It will be processed separately inside the zookeeper. All the manipulations you do on the table, it will be like every partition will be processed separately. So let's like some intellectual exercise. So if you have $5,000, how many wallets you need to store that? So do you need to have one wallet, or maybe 10 wallets, or maybe 500 wallets, or maybe 5,000 wallets? And for example, if you have money for few different customers, do you really need to have like separate wallets for all of them? And now let's imagine what you have. Okay, I decided I will take 50 wallets for that. And now I have one extra $10. I need to put that into to distribute that across those 15 wallets. So I can like $1 here, 50 cents there, 3 cents here, and so on. So you can imagine what amount of work I need to do with that. And when you do that thing with ClickHouse partition by tenant ID, you actually force it to, whenever you insert new data, like 100 of rows, ClickHouse need to put that those 100 rows, split that into those wallets, right? In every wallet, every row to its separate partition. You introduce much more work for ClickHouse. So it's called insert fan out effect. And like just if it happens once a day, it is totally okay. It's not a problem for like once a day you can put the distributor work and distribute that money between those wallets. But if you do that, if you're working on cache desk and you like a new data comes in like every second and so on, and you always need to work with all those wallets, you will hate that work and you'll prefer to do something else. So that means that either you have real-time inserts, either and in that case you cannot use that partition by tenant, or you don't use real-time inserts. In that case, you actually can do that. It's not a big problem in that case. With selects, the problem is not so big, but it's also visible if you need to do some cross tenant things. So, for example, if you need, I don't know, like we have like almost 500 wallets, and we need to calculate like I don't know, let's count taxes. Let's calculate 10% of all of them. So it would be much simpler to do that with a single wallet. Yeah. Yeah, but when I say that, usually the answer is but come on, I only have like 3 tenants. Why the hell should I like bother? But if you have 3 tenants right now and your business will grow, be optimistic. You'll have like 10 tenants in 3 months, like 100 tenants in 1 year, and maybe like 5 million tenants in 3 years or something like that. But if you do a decision by putting a tenant ID in the partition key, you don't allow your business to grow. That doesn't scale linearly. So how to do that better? Very simple. So simple. Just put a tenant ID, remove it from a partition key, and put that in the beginning of your profile. All the queries will work as good as the first option, and that way you can scale. Your system will scale up linearly. Yeah, and how to make it worse? Like quite quite a lot of people when I explain that, hey guys, don't do partition by tenant. Okay, I get it. Let's create like 1,000 tables. Or let's create 1,000 databases. It is the same actually, and it is not even the same. It is worse because every table have its own housekeeping work which needs to be done. So, for example, if you have replicated tables, with replicated tables, you need to check something in Zookeeper, do things, and so on. So it will worse. It will be even worse. So don't do that. Does it mean absolutely no? Well, it's as any anti-pattern. Sometimes you need to use that. So if you know some anti-patterns from programming, I don't know, like singleton, like a lot of people think that it's anti-pattern, but we sometimes need to use that. Same here. Yeah, if you understand what is happening, what can be like the downsides, what will happen with that, if you do that in a controlled manner, you can do that. But please, if you do that, understand what you're doing. And that's all from my side. Thank you, guys.
The art of creating an agenda is similar to the art of building explain statements, in that it feels deeply important and at the end of the day is often just an estimation. So in theory, if you look at the agenda, we have a thing planned. In practice, we're going to do something else, which is invite Alexei to the stage to talk to us about ClickHouse, building for fast. Alexei, welcome.
So this is not a lightning talk, so please be prepared. Let's ask a question. How to build a fast database? Or why ClickHouse is fast? It is very difficult to answer this question because if I have to answer, I will say, there is no single answer. There is no single silver bullet. Don't even ask. Instead of trying to answer this question, I will do some hand waving. I will show you some principles, ideas, facts, beliefs, and so on. But I will mostly do hand waving. So if you want to build the fastest database, how to approach this task? You may say, I will use the best algorithms. But it is difficult because there is no such thing as best algorithms. But you still can try. First, you can choose the best programming language. What is the best programming language? C++ or maybe C? Maybe Rust, it is more modern. Maybe I will need to write in assembly because it is fast. And if I will write my database in assembly language, it will be faster than ClickHouse because ClickHouse is using C++, and you know C++ is so aged already. Okay, if I need to parse JSON, I will use the best library. What is the best library? Seems JSON. Probably it is fast. I will use Apache Arrow to maintain data structures in memory. I have read on the internet that Apache Arrow is a good library. I will use memory method files, or no, I will make my database in memory because memory is faster than disk, and ClickHouse is not in memory database. And if I will write in memory database, it will be faster than ClickHouse because memory is fast. I will use asynchronous frameworks because you know what? Asynchronous should be fast, maybe. So probably it will be faster than ClickHouse. But actually it's not enough. If you will use all these principles, it probably is a bad idea. Let me show you one example. How to process JSON data quickly. Let's use the best library, simp.json. Yes, simp.json is the fastest library to parse JSON. If you are not sure, look at this guy on the right. Look at his face. He cannot be wrong. He has written this wonderful library, and he is responsible for this. And ClickHouse is using simp.json. And recently, there was a benchmark about command line tools to do queries on JSON. And this benchmark compared multiple tools like JQ, DSQ, TRD, SQL, Spark, SQL, Miller, SpikeQL, OctaSQL, and ClickHouse. There is a link, and unsurprisingly, the best performance is shown by ClickHouse. And also OctaSQL, it's like similar. And ClickHouse is using simp.json, and obviously it should be the reason of high performance, but actually it isn't. So ClickHouse is using simp.json. It is the fastest library. But it is using simp.json in a different context. We don't use simp.json to parse incoming data, to parse source data, to parse input. We use something different. So the question is, did we actually beat simp.json in speed? The answer is, it's complicated. Yes and no. And the reason why ClickHouse can process JSON faster is not that we use the best JSON parsing library. It's because we don't actually parse JSON. Instead, we just read first records. We learn the structure from these records. And then we use this structure to read JSON without actually do full-featured parsing. We don't need to really use full-featured JSON parsing library. You know, there is old Chinese poetry saying, if you want to parse JSON faster, you don't need to parse JSON at all. So use Chinese poetry and you will write fast code. Another observation. Every algorithm cannot be just fast. It makes sense in its own context. Let's take this example. I want to use the best hash function. What is the best hash function? Let's go to the internet and write a search query, fast hash function. And you will have overwhelming amount of results. 1GU hash, the fastest quality hash function. What does it mean? XX hash, extremely fast hash algorithm. If it is named XX hash, it probably has to be extremely fast hash algorithm. Aqua hash, fast hashing, just fast hashing. But at least they have some pictures. And it is very difficult what to choose. You have to consider where are you going to use this hash function. You can just implement it in SQL. So people will write select my best hash function or something. You can use it in hash tables. So it will be used when you do group by or join. You can use it inside Bloom filters. And every context is different. And what is even more paradoxically, imagine you will use this hash function in SQL, and your users will be able to write select my best hash function from table. And this query will be fast. But you cannot longer use the same hash function for hash tables. Imagine that your users will write like this: create distributed table distributed by remainder of division of this, the best hash function. And then the user will write a query group by X. But on every server, the lowest bits of this hash function will be unused because data is distributed by this hash function. So if you expose hash function in SQL, you cannot longer use it inside hash table. Too many details, too complicated. Okay, I have even more complicated slide. So, what is the best hash function? You have to look how it was tested. And there are multiple possible mistakes in testing hash functions. Imagine you will test it on strings of size 10. It is not enough. You have to test on every string size. On size 1 byte, 2 bytes, 100 bytes, and so on. Even on empty strings, it also makes sense. But it is also not enough. Actually, you have to test hash functions on different random distributions of sizes. Because if you will write a loop, and inside this loop, you will process the strings of the same size, you will make CPU branch predictor to do too easy work. It will be not stressed enough. The distribution will be not realistic. So you have to test on real data sets. It will be better. You have to ask, what if my data set has 90% of strings of size 0? And this hash function has to work well on this case. What if most of the strings under 100 bytes, but 1% of strings are exceedingly large? It should also be tested. You should, okay, I will not dig into all these details. But you have to always dig into details. If you want to build the fast database like ClickHouse, you don't have to. Let me show you one example. How many times you just load some website on the internet and the page has loaded in 5 seconds. So something is wrong. You hit refresh, you check again, and it is loading instantly. So everything all right. Probably it's a temporary glitch. It does not reproduce, so why even bother? But this is the wrong way. The right way is to ask yourself, why this particular my precious query was processed in 5 seconds? Let's find this single query in the logs. I don't care if million other queries processed quickly. I only care about my query. I expect that if you will write a support request, why your website loaded in 5 seconds? They will just answer you. We tried to reproduce, the problem doesn't reproduce, so forget about it. But if it is your website, you can look at the logs and figure all the details. So, another example. I have tested ClickHouse Cloud. I have tested queries using object storage and local file system. And in most of the cases, queries from object storage is not significantly slower, at least not more than 1.5 times. But in some cases, I see random latency spikes. So some queries are slower like 40 times. And this should not happen. If I just try again, different queries will be slower 40 times. But I have every logs in ClickHouse, and I can do this query to get query metrics and to compare query metrics. And it will look like this. And the reason became obvious. A slow query is reading 2 gigabytes of data from disk. And on these servers, we used to have very slow EBS volumes. So it is pretty easy. You only have to look in the logs. Another example and recommendation. So if you want to figure out why some query was slow, you have to do always on profiling, always on telemetry and introspection of your system. And we have plenty of options inside ClickHouse. We have a debugger like GDB embedded into ClickHouse. You don't have to install GDB. Just select from system.stacktrace, and it will show you where currently every thread is running. We are recording this data into another table, system trace log. It is sampling query profiler that you can use to draw flame graphs aggregated by multiple servers on the cluster for a period of several weeks. Or even you can get and look at one single query. And obviously we have query log, and we have all the metrics, including CPU-related metrics. So you want to know how many branch mispredictions was in your query. And you will see I have so many branch mispredictions. Probably I need to say, user, you have a wrong query. Rewrite your query. You can get this information from system query log. And what to do if you want to entertain yourself on Friday night. By the way, I assume you don't have family. First, run your program under a trace and explain everything that it will show. When you explain it everything, you can go to sleep. On Monday. Second, just attach with DDB and look at the stack traces. And again, explain everything you see. Run sudo perf top and look at the assembly. Even if you don't know assembly language, it looks beautiful. If you run a query and it takes 1 second, ask yourself, why not half a second? If you optimize it and it runs in 1 millisecond, ask yourself, why does it take a whole millisecond of time? 1 millisecond of time wasted. For what? You have to optimize. Okay, the next principle. Always design for production workloads. You cannot build a fast database management system sitting in some auditorium in University of Database Engineering, Minnesota. I'm not sure if this university exists. Probably not. But if you do, your database management system will be fast, but only on paper that you will write and submit to some conference. Instead, it is better to always be close to production, optimize for real production workloads. The more diverse workloads, the better. And do quick iterations, do quick releases. So you have to absorb the changes and react accordingly. By the way, this is the logo of one research system. I like this logo. About benchmarks. I like benchmarks. Some people collecting stamps. I collect benchmarks. Here is a link about every published benchmark for ClickHouse and how to approach benchmarks. You can make your official benchmark when your system is obviously better, but maybe it will not be very credible. Instead, it is better if all people on the internet will do benchmarks for you. And if your system will look better on these benchmarks, it will mean something. But not everyone likes benchmarks as I do. When I read acceptable use policy of some system, I found this. You may not use the offerings in order to benchmark offerings or to build similar or competitive products and services. By the way, they updated the terms of service. Maybe somehow they read my presentation. Okay, so my advice, do benchmarks, do more benchmarks. Don't prevent others from doing benchmarks. Don't do benchmarking. Let your users do benchmarks. Always continue experimenting. So, you know, ClickHouse is already well optimized, but can we optimize it even further? We can try multiple ideas, but we should expect that most of the ideas will not work. You have to select hundreds of ideas, you have to try all of them, and maybe one of them will work. One example, optimizing hash tables for group by. I tried prefetch, I tried SIMD instructions for lookups, I tried Robinhood hash table algorithm and even Swiss tables from Google. I tried to allocate more memory after the space in hash table to avoid wraparound. Difficult to explain. Yeah, I promise it's hand waving. But one idea worked, to predict hash table size in advance. So we collect statistics about to what point hash table will be resized. And we learn from these statistics and reuse it. And it makes a huge difference. So one idea worked. Another advice, rewrite code all the time. Don't worry, don't be afraid. And let automated continuous integration do the testing for you. You have to do automated performance test, integration test, fuzzing, and sanitizers. If you write code in C++ and you don't use sanitizers, your code is not good. And what about automated performance test? It is important not to only optimize one query and show that performance is optimized 50% on this scenario. It's always important to ensure that it does not decrease performance for every other query. What if you optimized one obscure scenario for 50%, but everything else degraded by 1%? It should not be approved. One example from my colleague, he asked me to put this slide into presentation, one of the most recent optimizations in ClickHouse. Optimization of sorting with just-in-time compilation. It was 5 seconds, and if I enable it, it is just 4 seconds. Plus 30% performance improvement, so thanks to Maxim. What else? How does automated performance testing look like? It looks like this. One contributor, Raul Marin, has optimized aggregate function sum with some batching or SIMD instructions or newer CPU instructions. And we see that yes, queries are optimized at 1.5 times. He don't have to prove. Our continuous integration system proves for himself. Another advice: test at scale. Test on overload. Test until it will break. And how to do this? I know ClickHouse works fine on databases of 100 trillion records. This number is difficult to imagine. It is even larger than the national debt of the United States. 1 and 14 zeros. And your tests should also run at scale, but it will be very difficult to load 100 trillion records on every test run. It requires hundreds of servers, hundreds of petabytes of uncompressed data, but at least tests should run at scale. One example: there is public dataset, Wikipedia page view statistics. It is available in public domain by Wikimedia Foundation, and it has 370 billion records, containing 1 billion of time series, page views on every article. I loaded this dataset into ClickHouse almost instantly after I noticed that this dataset exists. Then I loaded this dataset again. Then I loaded it in 10 different ways. I have loaded it into merge tree table, into replicated merge tree table, into replicated merge tree table on replicated database. I have loaded this data into S3, and I have loaded this data from S3 into ClickHouse. I have tested our ClickHouse cloud with this dataset. And now ClickHouse eats this dataset for breakfast with a speed of 40 million records per second. This is not me. Don't worry. But he looks very similar. Do weird things. Do weird stuff. You have to do weird stuff to challenge some beliefs. What are common beliefs about ClickHouse or misbeliefs? So ClickHouse probably is not good at loading large binary data. But what will happen if I will download about 5 million websites from the internet and upload these HTML pages into ClickHouse? And I did exactly this, and it went all right. So ClickHouse is probably not good if you do insert directly from JavaScript from web page. But I did exactly this. I built a service like Pastebin, and more importantly, I persuaded all my colleagues at work to use this service. And it went all right. Here is the service, pastiller.nl. What will happen if I will use URL table function to do 10 million HTTP requests? I tried. It did not go all right. But we have fixed it. And now you can do this. So ClickHouse, ClickHouse is not good as key value database. That's true. ClickHouse don't want to be a second MongoDB. ClickHouse is probably not good as a streaming data processing system. We are not Kafka. ClickHouse is not good as a search engine. We are not Elastic. And I'm happy that we are not similar to Elastic, by the way. ClickHouse cannot be used for search in vector embeddings, so machine learned search. But hold my beer and read the roadmap for this year, 2022. You will find many of these things that probably will be possible in ClickHouse in this year, or the next year, or 1 year later, but still, I want to do weird things and test what will happen. And the most importantly, why this picture is not animated. Tyler, why this picture? It should be animated. The most important is to have fun. You have to always have fun if you are software engineer, if you write C++ or even x86 assembly, you will always have fun. But the basic principle is do whatever you want if you can drive some conclusions and debunk some illusions. One example, I have loaded the first trillion prime numbers into ClickHouse. For what? I did not even ask this question. And the idea has no direct application. I just want to do this. And if you want to build a service displaying prime numbers, there is a more optimal way to do this. But nevertheless, I have tested ClickHouse Keeper, a replicated merge tree with object storage and replicated databases, and everything inside ClickHouse Cloud. And I have these observations. Everything worked perfectly. And one of the final. So how to have fun? Do you recognize this query, what it is? Yeah, it is this bus. Is it fast? What query is faster, this or this? And how fast is it? I will not give you the answer. I advise you to try by yourself. You should always have fun. I don't want to steal everything from you. So, what are the takeaways? How to write a fast database management system? You have to use good algorithms in a good context. You have to look into every detail, measure everything, work close to production, do benchmarks, do more benchmarks, never stop experimenting, test at scale, do weird stuff, and have fun. And my advice, get a life. Start contributing to ClickHouse. So, questions about how to make a fast database? Okay.
You talked about full text search. What about blue filters? What's your thoughts on how to improve those? Because we like them and we have a lot of users that use them, but they're pretty tricky to tune.
Mm-hmm.
And I'm just wondering what I know you like speed, and so how can we make this easier?
So the main concern is usability. It is difficult to choose the parameters for Bloom filters. So I don't recommend Bloom filters for everyone. I'm trying to keep it only for the most advanced users, like Lorenzo Mangani. You can use Bloom filters, but everyone else, probably not. I want to make them more automated. And currently, it is quite difficult to misconfigure the Bloom filters. So they will occupy more memory, but don't actually filter the things, and your queries will even become slower. And it is possible to make them more usable. We can even make them dynamically sized. So we will estimate how many unique values do we have, what the user will write, what false positive rate, do they want, and it will automatically select the size of Bloom filters, the number of hash functions, and everything else. So it is possible. Did you ever contribute to ClickHouse code base?
Documentation.
Only documentation.
Only documentation.
Mm.
It's a. I know, that's all, yeah.
Maybe you want to write some C++. Okay, by the way, I have a small gifts for every ClickHouse contributor. So I want to ask, how many people have ever contributed a single line of code or documentation into ClickHouse? Please raise your hand. Ah, great. Could you please give me? Okay, I will do it by myself. I have small gifts. So I want to give for every ClickHouse contributor. If you don't have more questions, we can continue discussing.
Are you satisfied with FizzBuzz performance?
What
Were you
performance?
satisfied by the FizzBuzz performance?
No, I was not satisfied totally.
I'm planning to optimize it.
I don't plan to optimize it because it will be too much fun. Imagine I will spend a month optimizing FizzBuzz.
We will have a lot of fun.
Yeah, but it's too much for me. I have fun every day, you know. I have fun with Tyler, with Ellen, with Yuri. More questions?
Cool. Thank you, Alexei. And having tested this more than once, I am now incredibly frustrated that the animation decides not to load, because Alexei's like express request was make sure that animation works, and it did until now.
So,
As I said at the beginning, go ahead, Alexei.
ClickHouse contributors. Let's. These are very small gifts, but they are very designated. You cannot get it easily. You have to contribute to ClickHouse.
So for those of you on the live stream, if you are ClickHouse contributors, message me, Tyler at ClickHouse. Hi. Message Tyler at ClickHouse, and we'll make sure that we take care of you too. And thank you. Awesome. So while Alexei hands this out, let me wrap. There is more food actually on the way. It should be here in a few moments. Folk in the back are doing things that folk in the back do, which is take care of us. As I said at the beginning, a meetup is only as good as the combination of the humans who show up and the content. It has been a bizarre few years, and I know I speak for myself and many others on the team. It really is a delight to see you in person again. So thank you. Thank you for coming. Thank you for showing up. I know many of you are from far-flung places. The next meetup that we'll be hosting in Europe is actually in Paris. After that, we're spending a bit of time, I believe, in Berlin and then London or Munich. Anyway, point being, if you want to talk, I'm Tyler at ClickHouse. I'd be happy to help you with that. If you want to write about how you're using ClickHouse, I'm still Tyler at ClickHouse, and I'd love to help you with that as well. It also takes a community team to bring together a community event, and the number of folk from ClickHouse who were deeply instrumental in making this happen. Ilya, Alyssa, Arno, to Rhoda today, helping figure out the beamer. All of the folk, greatly appreciated. Food will be here in a minute. Hang out to each other, talk, and thank you so much. We look forward to seeing you next time. Cheers.
Yeah. Yeah.